In this video, I'm going to explain you how to express sin x as a finite series in Lagrange form. So the question is explain sin x as a finite series in powers of x with remainder in Lagrange form. So since we want to express sin x as a finite series, we'll take the function to be equal to fx equal to sin x. Then we try to differentiate this. So if we differentiate fx, we get nothing but cos x. Okay, so I have cos x and I've written here sine pi by 2 plus x. So I'll explain you why I'm writing this. So you take here sine pi by 2 plus x. So sine pi by 2 plus x, it means it lies in the second quadrant. Okay, it lies in the second quadrant, so sine is positive, so here we'll get positive. And here it is an odd multiple of pi by 2, so sine will change to cos, so we have here cos x. So in place of cos x, I am writing sine pi by 2 plus x. So here I have written sine pi by 2 plus x, which is equal to nothing but cos x. So if I differentiate cos x, I get nothing but minus sine x. So minus sine x, so this also I can explain you here. We will have here sine 2 into pi by 2 plus x. That is nothing but pi plus x, which lies in the third quadrant. So in the third quadrant, sine is negative. Okay, in the third quadrant, sine is negative, so you get here negative, and it is an even multiple of pi by 2, so sine will not change, so it will remain sine, so we have here sine x. So minus of sine x is equal to sine 2 into pi by 2 plus x. So in place of sine 2 pi by 2 plus x, I have written here minus sine x. So minus sine x is equal to sine 2 into pi by 2 plus x. So similar way we can do this also. Now we'll try to generalize it. So when we differentiate first, here we have 1. When we differentiate 2 times, we have 2 here. When we differentiate 3 times, we have 3. So if I differentiate n time, I'll have nothing but n pi by 2 plus x. Then we are trying to apply the Maclaurin theorem here. So if I apply the Maclaurin theorem here, so this is a Maclaurin theorem in Lagrange form. So fx is equal to f0 plus x, f dash 0 plus x squared by 2 factorial, f double dash 0 plus x cubed by 3 factorial, f double dash 0 plus so on, plus x and x to the power n minus 1 by n minus 1 factorial, f to the power n minus 1 0 plus x to the power n by n factorial, f n theta x where 0 is less than theta is less than 1. So we'll try to substitute this value here. So now we are going to substitute the value here. So in place of fx, we get sine x. I'm writing here sine x. So we have f of 0. So f of 0 is nothing sine of 0 plus x. So x, f dash is nothing but cos 0. So cos x, so cos 0 plus x squared by 2 factorial, f double dash of 0. So we have here minus sine 0 plus x cubed by 3 factorial, f triple dash 0, that is minus cos 0. So we get this plus so on. Okay, plus so on, plus x to the power n minus 1 by n minus 1 factorial, sine n minus 1 pi by 2 plus 0, and the last term is nothing but plus xn by n factorial sine n pi by 2 plus theta x, because we have taken f of theta x, so in place of x we substitute theta x, so we get here theta x where 0 is less than theta is less than 1. Sine 0 is 0, so we are not putting any value here, and cos 0 is 1, so we get x, so we get here x. Sine 0 is 0, so this quantity will be 0, and cos 0 is 1, so we get here, from here we get minus 1, so we get minus x cubed by 3 factorial. And in the similar manner, if we proceed further, we get plus x5 by 5 factorial plus so on. Here we're getting x to the power n minus 1 by n minus 1 factorial sine n minus 1 pi by 2 plus x to the power n by n factorial sine n pi by 2 plus theta x, where 0 is less than theta is less than 1. So in the similar manner, you can expand cos x as a finite series in powers of x with remainder in Lagrange form. And for this, in the similar manner, you can find for ex also. So you proceed in the similar manner as I have done for sin x. So the next question I'm going to explain you here. That is how to obtain the expression of the flowing function with the remainder in Lagrange form. So this is your question. So e to the power we have here, e to the power x is equal to 1 plus x plus 1 by 2 factorial x square plus 1 by 3 factorial x cube plus 1 by 4 factorial x to the power 4 e theta x. So in all this question we are applying Maclaurin theorem up to the order 4. So we'll take here the function as fx equal to ex. So f dash x is also ex, f double dash x also will get ex, f double dash x also we get ex plus f to the 4. If you differentiate 4 times also we get ex. So we'll write the Maclaurin theorem of order 4. So we have here fx equal to f0 plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus x cubed by 3 factorial plus f triple dash 0 and plus x4 by 4 factorial f4 theta x. So we have here theta x. So we substitute the value here. So if you substitute here, we get fx is nothing but e to ex. So we write here ex equal to e to the power 0 plus x into f dash 0, so e to the power 0 only, plus x squared by 2 factorial e to the power f double dash 0, so e to the power 0 plus x cubed by 3 factorial f triple dash 0, that is nothing but e to the power 0 plus x to the power 4 factorial f the 4 e theta x, means f4 theta x. So here will be nothing but e theta x, but 0 is less than theta is less than 1. So you know that e to the power 0 is 1, so we get here 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus x4 by 4 factorial e theta x, where 0 is less than theta is less than 1. So that is the expansion of ex up to the order 4. So for this question also we are going to do the same thing. We'll expand, use Taylor's theorem, we use Maclaurin theorem up to the order 4. So we have here fx equal to sin x plus cos x. So if I differentiate sin x, I get cos x. If I differentiate cos x, I get minus sin x. So I get here minus sin x. The differentiation of cos x, we get minus sin x, and differentiation of sin x, we get we get cos x. Differentiation of sin x, we have here minus cos x, and differentiation of cos x, we get minus sin x. So minus minus will be plus, so we get plus sin x. So differentiation of cos, we get nothing but differentiation of cos, we get nothing but minus sin x. So we have minus minus will become plus, so we get sin x plus cos x. So we get this. These are the differentiation. I think you understand how to differentiate. So you just differentiate as usual. So after differentiating, you apply the Maclaurin theorem up to the order 4. So we have fx equal to f0 plus x f dash 0 plus x squared by 2 factorial f double dash 0 plus x cubed by 3 factorial f triple dash 0 plus x4 by 4 factorial f4 theta x. Now we are taking fx to be sin x plus cos x, so equal to f of 0. So here we'll have sin 0 plus cos 0 plus x. So we have cos 0 minus sin 0, so it's x plus x squared by 2. Just put these values here. So after putting these values here, f4 is theta x, so we get sin theta x plus cos theta x. So you know what is sin 0? Sin 0 is 0, so cos 0 is 1. So we put this value here. After putting this value here, we get nothing but 1 plus x minus x squared by 2 factorial minus x cubed by 3 factorial plus x to the power 4 by 4 factorial sin theta x plus cos theta x. So in the similar manner, we can we can also do for this question 1 plus x. Okay, we can do for this question. So that is one similar manner we can also find for 1 plus x to the power 1 by 5. So in the same way you proceed this. And here next question is about x plus h to the power 3 by 2. X plus h to the power 3 by 2. So here you take the function as f of h. So it is not depending on x, it is depending on h. So here you expand using that, and in the similar manner for this function, for this question also, log x plus h, you take the function as f of h equal to log x plus h, and you try to expand, then we get the proof to be nothing but this. So and there are some questions here. So you have to expand e to the ex cos x by Maclaurin theorem up to the term containing x cubed, means up to the order 3. So here another question is expand e to the power sin x and e to the power x into sin x as far as x cubed, means we have to expand this by using Maclaurin theorem up to the order 3. So these two questions you try. So you try to do this is in the similar manner as I have done before. So if you try in the same way up to the order 3, then we get the expansion of these drawing functions. Thank you.